Hey guys, welcome to our channel Robotics for Juniors. This video is very important as this is our first project into robotics. This video is about how to control hardware using a software program. The hardware is the LED and the software is the Python program. This is done using the powerful feature of Raspberry Pi, that is the GPIO pins. The purpose of the project is when we give command from the program, the LED glows, and on the other command, it turns off. So the physical component, the LED, is controlled by the software. But before starting the project, let's see briefly how this project is related to robotics. So basically in robotics, we control a robotic hardware like a moving car or buggy or a robotic arm by the software program. Through the program, we give a command and some work is done like movement by the car or lifting something by the robotic arm. So our project will be a first step into robotics because we will give command from the software program and the work will be done by LED that is switching on and off. So let's start our first project. The components required in the project are Raspberry Pi and its accessories, breadboard, LED, resistance of 470 ohms, and the jumper wires. Here is our circuit diagram. Here, the number in blue inside the circle represents the board pin number used for doing the connections, and the GPIO pin number in black is the BCM or Broadcom pin number, which will be used in the software program. For more detailed explanation of GPIO pin diagram, watch our video Introduction to Raspberry Pi. In this circuit diagram, the pin number 12 is connected to the resistance. Other end of the resistance is connected to the positive end of the LED. Negative end of the LED is connected to pin number 6, that is ground. This is the GPIO pin layout. We will keep these two, the circuit diagram and the GPIO pin diagram with us while making the connections of physical components. Before starting to make connections, let's have a brief introduction about the breadboard. A breadboard is a device used in educational institutions and by experimenters as it provides easy way to do connections of physical components without the need of soldering them. So it is a temporary method to do prototyping of the circuits. In the breadboard, this is the diagram which shows the internal connections. Below the sockets, there are electrical stripes which provide the connection to the components. In the middle, there are two blocks which have the connections in horizontal line. So two components connected in sockets horizontally will be connected together. Any component's two ends are therefore not connected in the same horizontal line. This will make the component in short circuit position. That is, the positive and negative end of the component are connected together and a very high current flows through it, damaging the component. On the two sides are blocks called the bus stripes. Here the connections are vertical. The sockets are connected vertically. These are mostly used for making the ground or power supply connections. So when more than one hardware component needs to be connected to ground, one point of this vertical line is connected to ground and then any other socket in the whole vertical line will provide the ground connection. This helps to decluster the connections on the breadboard. So let's start putting our components. We put this LED on the breadboard. LED in basic sense is a component which glows when current flows through it. The LED has terminals of unequal length. The longer terminal is the positive and the shorter is the negative. We connect it in this way. Both terminals go in different horizontal lines. The end of the terminal of the component should go all the way down to reach the electrical stripes below the plastic sockets. Now connect the resistance. We need 470 ohms. Ohms is the unit of resistance. For the start, I've taken the values of components and the circuit diagrams from the official website of Raspberry, that is raspberrypi.org. The main purpose of resistance is to protect the LED against the high value of current. Too high a value of resistance will make the LED glow faintly. That is, its intensity will be low. So 470 ohms will be good. I don't have 470 ohm exact resistance, so I have taken two resistances of 220 ohms each, which adds up to 440, which is close to 470 ohms. The color of my resistance is red, red, brown. So this makes the value of resistance 22 into 10 to power 1, so 220 ohms. For reading the color codes and basics of resistance, watch my video on basics and color codes of resistance. I have put the link below in the description. We connect the resistance to the positive terminal of the LED. Wherever the end of first resistance is there, put the first end of the other resistance. Now connect the resistance to the Raspberry pin number 12 on board. So the pin numbering starts from here, near this notch. It goes like 1, 2, 3, 4, and so on. So to connect pin number 12, we can count even numbers from here. 2, 4, 6, 8, 10, 12, and so on. We use jumper wire of any color to connect the resistance to the pin number 12 on the Raspberry. We use in this case male-female jumper wire. The end without the pin is connected to the Raspberry pin, and the other end with the wire is connected to the breadboard, like this. Next, the negative terminal of the LED is to be connected to the ground. It's a general convention to use black wires for the ground and any other color for positive connection. We use this black jumper wire to connect the ground pin number 6 to the negative terminal of LED. This completes our connection. After making the connection, make it a habit to check back your connections with the circuit diagram, because there is always a chance that we might have done some wrong connection somewhere. If it goes unnoticed, then it might damage that particular pin of the Raspberry Pi. So always check back your connections. In my circuit, the sixth pin number is connected to the negative terminal of the LED. The positive terminal goes to the resistance, and the other end of the resistance goes to the 12th GPIO pin. Now we make a program to send output to the LED to switch on or off. This program we will do in Python programming language. For this, click this menu option, that is the Raspberry icon. Go to Accessories and then the text editor. We will write the program in the simple text editor. So start typing by import rpi.gpio as GPIO. So rpi.gpio is a Python library used to control the GPIO pins. And writing as GPIO means we don't have to write the whole rpi.gpio every time. Instead, we can just refer to it as GPIO. Next, we import the time. Import time. This is to introduce some time delay between any two events. Like LED is switched on and after 2 seconds it will switch off. Now, we will tell the system that we will use the Broadcom convention, which is BCM. Broadcom is a general convention used for GPIO pin numbers. The other numbering system is board, in which we refer to the board pin numbers from 1 to 40. Please watch our earlier video, Introduction to Raspberry Pi, for more details on GPIO pins. So we write gpio.setMode gpio.bcm. Next, we set up the pin number GPIO 18 as the output pin, which is the pin number 12 on board, where we connected our LED, and we will be sending output to this pin. So we write gpio.setup 18 gpio.out. We will send output in the form of true or false. True will switch on the LED and false will switch it off. Here we put some print statements because in case our circuit has some loose connections or any issues and is not working, then at least the output is printed to show that the software program is working fine. So print LED switching on. Now switch on the LED. GPIO dot output 18, true. Now give a delay of 2 seconds. Time dot sleep 2. Now a print statement again. Print LED switching off. And now switch the LED off. GPIO dot output 18, false. But before ending the program, we will have to release the pins used for output. Else when you run the program next time, the system will give warnings of the pin being in use already. So we type GPIO dot cleanup. We save the program now. We put the extension of file name as py because we wrote the program on simple text editor. So this extension shows that this is a Python file. Now to run the program, we open the terminal or the shell as it is sometimes called. Here type command pwd. This gives you information that which directory we are currently in. Then type ls. This gives a list of all files and folders in your current directory. Then we need to go to desktop where I saved my program file. So I type cd desktop. It means change directory and go to desktop. Now type ls again. ls. This gives again the list of files and folders. Here is my file ledbasic_python. So we want to run this file. So type python ledbasic_python.py. That is a python space in the name of your file. So this switches the LED on and prints output also. Delay of 2 seconds and then the LED switches off. So this is it. This completes our first basic program in robotics. Please give the feedback by either liking the video or commenting whether you were able to follow along with the tutorial. Subscribe to our channel, Robotics for Juniors, for more projects. See you in the next video with another project.